Hello, everyone. Thanks, all of you, to be here. My name is Chander Dhall, and I'm going to be the moderator for today. And we also have Justin Weiler, and you can probably see Justin right now, the CTO of FatCloud. Uh, just in case you're not able to hear us, you can always log back out, get back into the meeting. Now, I just said that, but if you can't hear us, you can't hear this either. So let your friends know. We're very excited to have this go for you today. You can also ask us questions during this thing is going on, and I will be looking at the chat window, and we can bring up the questions whenever it's a good time to take a break. I think we'll go on for about an hour, and this is a very exciting topic. I've been talking about NoSQL for a while now, and recently Microsoft published a book, and so we have the topic for today, which is why does Microsoft care about SQL and NoSQL? And why does it care about polyglot performance, which is really saying different kind of databases together. And the next slide basically covers some of that, which is going to be the agenda for today. Well, so Microsoft recently published a book which talks about this kind of stuff, and that's the book right there. I think it's on Patterns and Practices website, and I bet you can get it from there. A great book, by the way, good read. And the agenda for today is what is NoSQL? First of all, a lot of people think of NoSQL as the no SQL at all, which is not the case. It's not only SQL. What's polyglot performance, or what is really hybrid NoSQL and SQL solutions? How do you integrate both of them together? And why is it important? What's the benefit of having a hybrid .NET ecosystem with SQL and NoSQL? And what are the benefits? What are the things that you can reap the best out of a NoSQL? What are the things that a SQL does really well? And then how do you get there? A lot of people talk about it, but what's the good solution, especially when it comes to the .NET ecosystem? What's a good solution? We're going to cover most of this, obviously, and a lot of other things that are related. So feel free to jump in with questions like, hey, I'm in this kind of situation here, and I'm using this and that, and I'm in this kind of industry, and what's the good solution for me? Because we're here to answer all your questions. Moving to the next slide. So what's NoSQL? Like I mentioned, not only SQL. So really speaking, NoSQL was something that came recently, and it became important recently just because we're going in terms of scaling out. And when I say scaling out, what I mean is, can I add 50 servers to my application today rather than just going scaling up? What's the problem with scaling up? Scaling up really means that I have this one big box with X amount of different cores, let's say 32 core CPU and 100 gigabytes of 96 gigabytes of RAM and whatsoever, and then there's a limit to it. There's a limit to the capacity, and it gets expensive. How do we use commodity level software and move it out, scale it out? And once we scale out, how do we do it easily so that I don't have to actually go and redesign my whole app? What's the best way of doing it? Why do we need it? Well, 10 years ago, how many of us really had these many smartphones out in the market? And how many of us really kept pinging websites? It's just grown. It's grown tremendously. We have about 7 billion people in the world, and we have about 9 billion devices. So you imagine that are actively going on websites and really trying to ping these websites, and you got to be responsive 24/7. Fault tolerance, another important thing. Now, I make a request for data, and something happens, and your data center is down. Well, if your data center is down, do you have a replica of your data center somewhere? Well, let's not even go to the data center level. What if your node is down? What if that particular server is down? Do you have mirroring, replication? Do you have any of those things that make sure that you are not down, even though some of your servers are down? Schema that. When it comes to doing any kind of RDBMS, we have schemas that we have to define beforehand, and all of us know how easy it is, and I'm just joking in here, what a pain it is to actually change the schema. So how do we handle unstructured data? The UI mostly is unstructured. It's JSON. And we think in terms of structured data, especially when it comes to SQL, where we we have to go and define the data, give it a schema, and then anytime we change it, we have to go through this whole process of being able to add that one property that never existed over there. And now imagine removing some of those. And again, there are tons of tools that do it, but again, do we want to do it when we are having a lot of unstructured data? Maybe the answer is not. Being eventually consistent as opposed to being fully consistent. Now, you're a company that has something to do with financial stuff, and I fully agree that you have to be fully consistent most of the times, especially when transactions involving money are concerned. But what about the other scenario where, well, do you really care that you added a friend on Facebook and he shows up right that next moment? Do you worry about it if he shows up 30 seconds later? Probably not. You know, there is a post that you commented on and it shows up at that particular moment, and that's okay. But you purchased something from Amazon and then you got an order ID, but for next 2 hours there is some back order processing that's going to happen, but do you really care when it started happening? All you care about is the time when your order leaves Amazon. So those 2 hours are really not important to you at all. You just want to get notified with an email because your stuff is not going to get shipped that very moment anyway. What you want to do is have a great user experience, click and go because you ordered, right? And that's where eventual consistency becomes important because you don't have to be fully consistent every second. And now there are several approaches. You know, there are key value databases, there are document databases, there are graph databases, and you have tons of these databases out there. And this is the biggest issue. With NoSQL, I have so many options that it's actually hard to go right. I mean, because I'm so confused as a general user, right? I did a talk recently where I compared 12 different NoSQL databases, and everyone had its own advantage. But the best kudos I got was for the last part of my talk where I said, okay, well, I can use only one of these to do what all 12 of these do really well just by making some algorithmic changes, right? And that's what's important. You cannot just go and start picking every single thing out there to do the best possible thing that you want to do. And in the most ideal scenario, go for it. But again, you have to think in terms of ramping time for the developers, you know, learning new languages, learning new paradigms, and then when it comes to .NET, there's not a lot out there, right? But that's why we're here today, and we're going to discuss all that and give you the solutions that you want. So the ideal scenario would be you giving us a business case, or we talking about some business cases and saying, okay, this is how you make it work when it comes to a NoSQL and a SQL hybrid. And moving on to the next slide, here are just a few of the NoSQL databases. In fact, one of the best ones that I love, Elasticsearch, is not there. I mean, because a lot of people think it's a search database. You know, actually it's not. It's again a NoSQL database, which really does search really well, but at the same time does a lot of what you see a lot of these databases doing. It does that too. Now, starting from Cassandra, and everyone knows that Cassandra is amazing at write. In fact, one of the fastest NoSQL databases when it comes to write, you know. And then if you look at Couch used to be great, and then Couchbase is a little different. It's going more towards a key value pair where you might know Memcached or you might know Redis, which are more key value pair databases. Really fast on retrieve flow. They give you the value you need pretty much instantly, right? Going more towards the document databases, which is Cassandra, Mongo, Couch, you know, UC more, even Raven, FatDB, these are document databases. They have more functionality and they support a lot more features than something with a key value pair database like Memcached would do. But they might be a little slower. And now that's debatable. It depends on the business case. There are business cases where FatDB is actually faster than Memcached. You know, it totally depends on the business case what you're using it for. But the idea is using something like a document database, you are actually going towards a paradigm where you have features that are pretty much close to a SQL server. Maybe not as good on reporting and other things, you know, but pretty much competing with SQL Server. And on the performance side, way faster than SQL Server. Now, if you go into other databases, you know, like Neo4j is pretty much a graph database. And when you're writing a social network, maybe Neo4j is a great choice, right? Now, we already talked about a few options here, and it starts getting confusing. What do we do when we have to go the NoSQL route? You know, I'm probably better off being a SQL guy because, oh, there's so much of this and I got to learn, and not a lot of these actually work that well on the .NET platform. Except I think two of these I can see, FatDB and I think RavenDB are written in .NET, right? Again, moving on to the next slide. Comparing the SQL and the NoSQL paradigm. Now, it's a different storage model. A lot of people say, I cannot move on to SQL from a SQL server to NoSQL database because I want it to have ACID properties, which is more like ACID, which is atomicity, consistency, integrity, durability, right? And that's a pushback I get all the time now. Most of the times I've countered back saying, have you ever used a unit of work pattern in your application? And the answer is yes, because you have to handle transactions or the unit of work at the application layer, right? So if you're already handling the transactions at the application layer and not at the database layer, well, maybe at the database layer too, but it doesn't remove the possibility and even the need of handling that at the application layer. Then in terms of NoSQL, you'll always do that anyway. So I think it's not about that NoSQL doesn't handle ACID properties or it's not ACID. Some of them are actually ACID. But it's more about the thinking behind it, that can we handle that at my application layer? Yes, I can. And if I can, then that criticism doesn't really hold well. Moving on to the next slide. If you look at the NoSQL strengths and weaknesses, one of the biggest strengths is scalability. Now, we talked about having a big server. Imagine the biggest server that you ever have. It's got to have a limit. Now you have tons of these servers, right? And now you want to incorporate something because all of a sudden you realize that you're getting 10 million hits on Thanksgiving. How do you scale out? Well, when you scale out, the multi-node scalability strength of NoSQL is probably the best because you can scale out without having to worry about anything. Now, there's a caveat. If you actually write your application that doesn't scale out, that's a separate story. But if you're creating a stateless app that does not matter on any kind of sticky sessions whatsoever, it will scale out. And when it comes to the NoSQL paradigm, you've got to do it that way, right? And that's something that you will do if you start NoSQL first. What's the weakness? The weakness is guaranteed data consistency is not there. Eventually, yes, but at that particular point of time, probably not. Let's take an example. You were to make a change in your employee record, and you said, okay, well, let me go and make a change in the employee record and change the last name to something else. You went from X to Y. When you made that change, the change happened on one server. When it happens in the major, and let me call that a master, it happens on the master node. The moment you go from the master node to the replicas, it's going to take time. And when you did a query, you might have queried one of the replicas, depending on the algorithm behind the scenes. So what you do get is data which is a little stale. Now, you don't get data which is wrong. You just get data which was not the most updated data. However, a few seconds later, when it's actually updated, you still go and make a call. You still get the same data that was actually updated. Now, like I said, if your algorithm on the NoSQL is right in the first place, you might have actually gotten the data which has the best versioning. And I totally agree that this is a very simple case where you would think, well, why would it not get back to me? It's pretty easy, right? But think in terms where it's a much larger scale and the update was a lot bigger than where it was. In that case, you can have eventual consistency, and you may not have consistency at the same particular instant, and that's a little bit of downside. But again, when you're scaling systems, I think you can only get one of the two from the CAP theorem. And CAP theorem says you can get two of the three, which is consistency, availability, and partitioning, right? Out of the three, you'll only get that. Just like a triangle. You have consistency, partitioning, and availability. And you can choose the best of the two. But in the long run, it solves a lot more problems than what it otherwise would with a system which is only going to scale up. And moving to the next slide. Here's a good comparison of SQL and NoSQL. We talked about the consistency model. One is fully consistent, and it comes at a cost. The other one is eventually consistent, but there are a lot more other benefits. When it comes to scalability, we have one server, pretty much. Now, why do we say one server? A lot of people will ask me this question, like, well, I can take my SQL server and I can start creating more servers, and I've done that. Yes, you have, but do you get the benefit of the schema? The moment you go from one server to the other server, you lose the benefit, the inherent benefit of being a SQL server. At that particular moment, you do lose that schema anyway. So if you're losing the schema, why not move towards a NoSQL solution or even a hybrid solution where, let's say, 20% of the data stays in SQL Server and 80% of that in the NoSQL server, especially the data that needs to scale. And if there's data which is financial, related to a lot of other things, needs a lot more security, that probably stays in SQL Server. Fault tolerance. Now, fault tolerance is important. We've talked about it, right? Your server's down, something happens, the secondary fails, or even the master fails. What happens when you have a master and you have two secondary nodes? Let's say the master fails. These two secondary nodes, one of them automatically becomes a master. There's got to be an algorithm in place that makes a master, right? And now you are back up again because even though your master was down, the two secondary nodes were there and they have the data that was replicated from the master itself, right? So that's important. Fault tolerance is really important. Data design. How about designing a system where you don't have to worry about schema? How many of you actually write code that your schema doesn't change? I bet the schema changes way more often than we think it does. If your schema were to change every 1 year or two, I would not worry about it. But if it changes every sprint, like it does for me, every 2 weeks I have to change the schema, it becomes a pain. So in case of database design, you have to actually design your database really well. You cannot get in the market right if you do not design the data first. And every time you have an update, it's a pain. But on the NoSQL side, you do have schema-less data, and once you have it, you're good. But if you want any changes, you can always do that. Because at the end of the day, you do not worry about duplicating your data because you have so much space. All you have to do is add another server or set of servers, right? So what happens if something goes wrong with that schema? You add a lot more other things and then change the document. Schema doesn't matter. So imagine a situation where you have a date type which you put a date in a particular format, and then you want to change the format of that date, right? In case of SQL Server, you will have to go and even make a change in the property because it's not going to support that, right? But in case of NoSQL, you can do that. All you have to do is write another line or even the data type. You don't even have to change anything. You just give it the value, change the value to something else. It's going to support it. Imagine where you have a SQL server with 5 columns, and now what you need to do is in the same table add more columns. In case of NoSQL, all you do is add the next 2 columns, and you're good with that. So data types, we've got relational database. On the other side, we talked about unstructured data. The strength, SQL Server is fully transactional. It really has a really awesome reporting and tooling capability, but again, it's been there for 30 years, and it's really good with that kind of stuff. On the other side, NoSQL, the biggest benefit is scale, performance, ease of use, ease of development, and adoption. You got to get to the market now. What do? Well, pick up something which is NoSQL, throw your JavaScript client, tell your guys this is your API, this is what you're going to expect. UI guys go on a side, create the thing. The NoSQL guys go on a side, create their thing. You come back, you merge it. There are some schema issues, doesn't matter, because you can always change either of the sides to make it work. And that's how it is. Now, next part of this webinar, I would like to go and try to question Justin here, who's an expert on this thing, because he is the one who actually develops FatDB. He leads the team, and we're going to talk about all that stuff. But before that, Justin, the topic today is Polyglot Persistence, right? And understand it's a term that it got started by Scott, and then Martin Fowler picked it up. So what does it really mean?
That's a great question. You can view polyglot persistence on a couple levels. One is that you have a flexible data model where you can store transformations of the base data in separate formats, like, say JSON or POX or whatnot. But in a much broader sense, it really refers to creating a hybrid data store where you take the best of the RDBMS camp, where you have great BI and reporting tools and wonderful transactional integrity and ACID characteristics, and you combine it with a NoSQL type of tool which provides eventual consistency based, super high scalability, lots of flexibility in handling your data models, very schemaless, and it's very adaptable to modern business needs. So if you're really going to talk about polyglot persistence, you have to really encompass all of those things. So let's move on to the next slide. So in practice, what does it really look like? At a very high level way, you have an application that talks into your cluster, and at the bottom you can see that we have several possible data sources that we can draw upon. We have a relational database for heavy denormalized relational types of data. We have a document database for very free-form type text data. Typically you'll find that in, say, medical records or legal documents, or blog postings, etc. It's very hard to model documents in a relational database. Key value store. A key value store is something that one may want to use for something that they know what they want, they just want to go fetch it. And a key value store tends to be perfect for that. And something that's rather hybrid of these approaches is a column family database, very, very popular, and that just allows you to have a very flexible data schema. But the idea is that you have a web service or some sort of other facade. You have some various data access layers that will abstract the access to these data sources. And together, having these different data sources is really a hybrid database. And this is what it looks like in like a production environment, for example. So its most basic incarnation, how would you go about building just a simple hybrid database? And what are the fundamental concepts? The idea is that when you have calls for, say, relational data or transactional data, things that you really want to keep in your SQL Server, you go ahead and you route your calls to your SQL Server for this data. But there could be some tables that are really just read intensive, really read only. So here's a perfect example. Let's take like an e-commerce site, and you have some catalog data that is accessed quite a bit, right? You have products, they're not updated all that often, but in order to display your website, you're accessing that data quite a bit. A real simple way of doing it would be to move that data over to a NoSQL cluster and have the NoSQL cluster handle all those requests and essentially take the load off of your SQL Server. So now you've effectively created this hybrid environment, integrated SQL with NoSQL, and immediately reap some benefits. Another possible use case is, let's say you have some unstructured data, and it would be a real pain in the ass to try to model that in SQL Server. So why not just take these documents and stick them in a repository, a distributed repository, so that you can retain some of the same semantics of querying and reap the benefits of being able to access this flavor of data that you wouldn't normally be able to easily do through SQL Server. So, this is what I like to sort of think of it as is kind of, this is data-driven request routing. So if you need more of relational or transactional, then you route your request to SQL Server. If you need something that is super read intensive, lots of traffic, go ahead, or unstructured, go ahead and route it to your NoSQL database. And at its highest level, that's the easiest way of thinking about this. There's another characteristic, though, that when you start talking about integrating SQL Server with NoSQL, you really want to keep in mind. There are a lot of use cases that involve updating data. So what I mean by that is data is not really static between your NoSQL cluster and your SQL Server. Say I update my product catalog. I would like to propagate that update to my NoSQL cluster so that my customers can immediately see the new product data. Let's say that your NoSQL cluster also was hooked to a web portal that allowed folks to, say, enter their own products. Rather than route those requests to SQL Server directly, what you could effectively do is have your NoSQL cluster take those writes and eventually propagate them back to SQL Server. So an important characteristic that when you're integrating your relational database with your NoSQL database, you should consider picking a software suite that has some level of automatic synchronization between the two components. So right now I used FatDB as an example. Our product happens to be able to do that. There's another product on the market, I think through MongoView, you can manually do it. I'm not aware of any automatic option. So let's take sort of another look at this more from a consumer perspective, and see step through why this synchronization is important, how it works in practice, what you can expect when you're rolling it out. So at the bottom we have our SQL Server cluster, and we also have our existing legacy apps that we've already written that read from and write to SQL Server, as well as we've invested in our BI and reporting tools. So the example of this is that our legacy apps can continue to do CRUD operations on SQL Server. But on step number 2, what we do is we propagate these changes up to a NoSQL cluster. In this case, it's FatDB. And we're primarily looking for an automated way of doing it so we don't have to do it ourselves. Once it's in the cluster, step number 3 is that our new web clients or our mobile clients can access this cluster and reap the benefits of having it distributed, lots of scale, and they are not pounding on your SQL Server. So you can potentially avoid an upgrade if you have this NoSQL cluster in front of SQL Server. Now, any changes to the cluster get propagated back to SQL Server. That's step 4. And they're immediately available to your BI and reporting tools. So that's a real win-win there. That's a concrete example of how we could use a NoSQL cluster today to benefit performance. So in Microsoft's book, they asked the question, why is a polyglot or a hybrid database or data store important? Before NoSQL, we really didn't have many options. We were pretty much forced into the relational data model, or we had to write our own. The realization came several years ago with some pioneers like Google and Amazon and whatnot, that this data model was not serving well, especially as sheer volumes of data increased and the web properties started getting crazy amounts of simultaneous users and transactions, and mobile apps exploded overnight. There needed to be a better technology for handling this these data needs. So the realizations were really twofold. One is that one size of database or one flavor of database may not fit everybody all that well, and we can use the best tools or tool set for the job now. So you're no longer constrained to just picking SQL Server and forcing all the essentially a square peg in a round hole. You can
And here's a study I have from both Amazon and Google. So Amazon claims that just an extra 1/10 of a second, which is nothing but 100 milliseconds, an extra 100 milliseconds on the response times will cost them 1% in sales.
Wow.
That's billions of dollars, right? And Google validates the same thing by saying half a second increase in latency, which is like 500 milliseconds, caused their traffic to drop by a fifth. That's like 20% of their revenue can go down, right? And that's where it's important to see that, we can have all these systems, but we need to have a system that scales out, gives scalability at the same time performance, because between 100 to 500 milliseconds, we've just lost billions of dollars, and that's why it's important.
Yeah. Yeah, absolutely. We've had clients that have basically tried to use SQL Server for massive scalability challenges, and the bottleneck was so severe that unless they actually changed the way that they were thinking, the application didn't work. So there are some very distinct use cases, not just for folks that want to scale, because that is important. Being able to handle lots of users and lots of lots of data, lots of servers, but NoSQL is also important for folks that aren't interested in maintaining schemas all the time, or paying the overhead for doing it. You can kind of approach jump right in and do your application and not worry about getting everything perfect in the beginning. As your business needs evolve, you can adapt the data storage without having to incur significant penalty of restructuring your schemas and rewriting your code. That's a very liberating set of capabilities for NoSQL. Just as the schemaless aspects alone are important, and you add the scalability aspects on it and the cost effectiveness on it, and it starts to become a real compelling solution. So, but in the same note, folks have a significant investment in SQL Server, and there are some things that SQL Server does exceptionally well. So the thinking today is to combine them to have the best of both worlds. And if you do have a hybrid solution, you can be more scalable at less cost. You don't have to change your legacy apps. Your time to market, for the reasons I mentioned, is radically reduced. There are certain sets of application functionality that don't exist on SQL Server, that are fairly easy to implement if you went with a hybrid solution. You can still use your BI and reporting tools on the SQL Server side. And here's a really good one. Point number 6, which is improved data mining. There's, especially with unstructured data, there were some challenges in really mining that data and making, effective business decisions on this. Because there's, really no easy way of storing it, no easy way of retrieving it. Now with the advent of technologies like NoSQL and, related things like Hadoop, you can do some amazing data mining that can really maximize your overall business intelligence. And finally, superior elasticity. And what do I mean by that? And superior elasticity effectively means, let's say that you have a mobile app that you create, and you have no idea that it's the next best thing since sliced bread. You put it online, it's an immediate smash hit overnight. Instead of getting the 5,000 users that you were wishing, you get 5 million. Scaling, writing an application that can scale 5 million users is very different from writing an application that can scale for 5,000 users. And one of the great characteristics of NoSQL technology is that the idea that being able to rapidly and elastically adapt for scale is part and parcel of the technology. So if your scale demands are a big, void in your business plans, you may want to consider having NoSQL technology in place to be able to handle unpredictable, peaks in load. So this last slide that I'd like to address is I asked myself the question, what tips would I give a friend if they were going out and trying to roll out a hybrid solution? They were interested in the technology. They've never really done it before, but they like what they see and they're sold on the idea of being able to bring those kind of capabilities to their enterprise. And so I try to encapsulate the 10 tips that I would recommend of the things that I consider to be the most important things that you have to do or think about or plan for when you're doing this large-scale application or this very agile application. And number 1 is thinking holistically. And this can be a challenge for a lot of people. And what I mean by this is that you can't just consider your data layer. You can't just consider your web layer. You can't just consider your business processing in a vacuum and expect that you're going to be able to write these things in a vacuum and hook them up, and that everything is going to work in harmony. You have to think about the big picture. You have to think about what it is that you're trying to do, and now, and how you want to do this in the future, because your business needs may change. And one of the most important parts of this is that you do your traffic and data analysis. And what I mean by that is you have to understand at some fundamental levels what kind of traffic that you're going to be experiencing, at least as far as order of magnitude goes, and what kind of data that you're going to be serving. Because from your traffic and data analysis, you can decide on which data sets you want to move into NoSQL, and you can decide which data sets you want to keep in SQL Server. That's a really important aspect of building your application, and you're constantly going to be doing traffic and data analysis as your application evolves. The next most important thing is testing and metering. You have to know what your traffic, what kind of latency your traffic incurs. You have to know what kind of capacity that your architecture has. if you don't do your testing and metering, you could be faced with a situation where you have your 5 million users, and the next thing that you know, your architecture crashes because you didn't do your due diligence. The
So
next thing I
here's
go ahead.
a question, Justin. So one of the so Derek asked a question saying, when you say it has superior elasticity, what is it superior to?
Its superior elasticity, I would say, is it's superior to SQL Server for one and only solution as far as storing your data goes, because in order to be elastic, or in order to handle more demand for, say, SQL Server based traffic, you have to scale up usually. And scaling up, it tends to be very expensive. You have to get the hardware in place. You got to move the data. Whereas with NoSQL technologies, you're finding that you're running out of scale. All you have to do is add servers. And a well-constructed NoSQL database will automatically incorporate those servers into the mix without you having to do much of anything. And the response times in scaling up versus scaling out are radically different. On the flip side, let's say that scale goes down. You can take those servers that you added to your scale out solution and repurpose them. Once you've gone and bought like a 24-core box SQL server, and it turns out that your business needs change, or your scale changes, and you no longer need all that horsepower, you still have a 24-box SQL Server and 24 SQL Server licenses. So that's what I mean by elasticity. Okay, so tip 3, what you want to do, this is always best practice, is to minimize architectural complexity. Think in terms of missions rather than discrete services. If you can do something like Hadoop does, which is, for example, cluster their processing with their data, you immediately reap benefits of speed that you would not get if you had just discrete services. So if you could cluster related technologies into discrete groups of machines as sort of missions that we like to call it, that helps you on the scalability side, because then the problem is not scaling out individual services, it's scaling out a mission. And since everything is interrelated within that mission, it becomes a much easier proposition than having a highly decoupled strict SOA. Number 4, minimize your glue code and your impedance mismatches. If you have 20 different a la carte piece components, you're going to have a little bit of a system integration challenge. You got to make that work. Try to reuse code where possible, or look to a more integrated framework. Cut down on the pieces, the number of moving parts and the amount of adapter code that you have to write, and you'll be ahead of the game. And standardizing also means making standard data access layers and abstracting that into reusable components that you could reuse across your enterprise. Number 5 is really important. Don't paint yourself into a corner. A lot of enterprises make these purpose-built applications for a particular business mission, and it's highly tuned, it's highly targeted at what they're trying to do today. You don't necessarily know what you're trying to do tomorrow. So if you can give yourself an out, understand that you may want to change your business requirements in the future and code your architecture that way, you'll be better off than if you paint yourself into a corner.
So here's a question I answered privately. I just wanted to make sure that we answer that publicly. The question is that, so if you have a hybrid solution, does that mean it's going to have less elasticity to a complete NoSQL solution? So the way I think of that is, yes, but it's going to be pretty much close to a NoSQL solution. It really depends on how you design it. how much data
Exactly.
you have in your NoSQL and how
Yes,
much data you have in
exactly.
your SQL. We've done that with quite a few of our customers, and the way I put it is that it's going to be still closer to a NoSQL solution, and it
Yeah,
should also be equal
it
to it.
depends on how you slice, how you distribute your data. So
So
there are a
someone
couple more
talked about
questions.
parallel data warehouse. I'm not sure if I understand that question, but do you want to comment on that?
Say again.
The Microsoft offering for the Microsoft parallel data warehouse offering.
I'm not familiar enough with the capabilities of it to really you know address that. Um, but I will look into it. So, I mean, do you know about that, Chander?
No, I haven't actually heard of it. I don't know if is that something related to Azure. If it is, then I should be able to get you some information if you just
Yeah.
send us an email, which will be shared at the end of the talk, and then we can get back to you. Good question.
Okay. Um, okay. Do you wanna postpone the questions until a little bit? I'm almost done with the tips, and then we can handle some questions
Sure.
and go forward.
One of the questions is, do you have a demo for this
Um,
today? I
we
know we're running out of time, but if you
Yeah,
have
we
something.
do. We're running out of time, so let me whip through these last tips, and I'll abbreviate it, and maybe we can show a little bit of product, some cool and exciting stuff that we've just released. So, maintenance and configuration overhead tip 6. Remember that you as developers, any solution that you put in the field, your maintenance guys have to maintain and configure it and be kind. Portability and flexibility. If you're going to look for technologies that gives you NoSQL characteristics, portability and flexibility are pretty important. You want to be able to run this solution just about anywhere, in your own machines or in the cloud. Again, you don't want to get vendor lock-in where you can't, effectively move or be held hostage on an Azure or Amazon public PaaS. You want to be able to maybe move it into your own data center if security becomes a concern or whatever. Strong RDBMS integration. This is kind of a no-brainer. The fact that we're creating a hybrid database means that the more RDBMS integration hooks that you have, the better. An integrated extensible framework. This is really important because if you're going to be building a web scale enterprise application, it would really behoove you to pick an actual framework that allows you to write a lot less code. And there are just a handful of them out there with varying capabilities. I think all the rest of them are on the Linux side. FatDB's the only one for .NET, but again, this goes back to thinking holistically about your entire enterprise application, not just your database. And finally, good support and resources. You can't really build these things in a vacuum. That's one of the reasons why you're on this webinar today. So find a vendor that has good support and resources, and you'll be well off. So that pretty much concludes the presentation. I know we have a bunch of questions. We have a demo that we could jump into if you'd like. I'd like to take a second to encourage everybody to go to our website and download our technology, kick the tires. I think you'll be pleased with what you see. But without any further ado, let's get to the questions.
Sure. So I think we can move to the demos, and just for the emails, I think this is my old email, and this works. But the new email is me at my first name last name.com, which is chanderdhall.com. So I think, Justin, we can move over to the demo while I can answer the question on parallel data warehouse. Actually, I was aware of it. I just did not know the term. So yeah, that is kind of integration of SQL Server with Hadoop. And that's a totally different thing that we're talking about here. That is where you really have big data involved, and you have to do a lot of things that Hadoop is really good for, and then you can integrate SQL Server with. Definitely a great business case for a lot of applications out there. What we're talking about is a generic use case where you can start, as a startup, mid-sized company or a large-sized company, whatever. You start with your with a small application, get to the market fast, and you don't have to worry about scaling because you can still do it. Now, Hadoop in itself has a different business case. So I don't want to compare the capabilities, but if you were to say Hadoop, if you're interested about talking about Hadoop, then I think you should have a lot of big data involved because, like Amazon Redshift, 10 times faster than Hadoop. Now, do you really have that much data that you need Hadoop for to begin with? And that's very few systems in the world, right? And so it's a different use case. We can go into length and details about it. I don't want to get there yet. Probably not a great forum to discuss this, but we should be able to do another webinar or something specifically addressing that kind of question later. But as of now, we got 8 minutes left, and I would like for Justin to go with the demo.
Sure. What you guys can see on my screen, hopefully, is is our management studio. This is kind of an old version that's up on the website, but the version that you download today has been made a little bit prettier and some more functionality. But I want to call your attention to this this left-hand side. What we did for folks that are used to using SQL Server is try to create a GUI that mimicked a lot of the visual aspects of SQL Server Management Studio. And this side tree view really tells a very powerful story about our product. And I want to call your attention to what you can see here. So effectively, what you see here is not only all of your NoSQL data stores, but you can see your distributed file stores. You can see your distributed work queues. You can see all of your servers, all of your environments, all of your groups. When I mentioned integrated platform before, as far as the tips go, not only is FatDB, a NoSQL server, but it has all of these other capabilities that allow you to complete the holistic picture. You're going to want to manage data, you're going to want to manage files, you're going to want to do processing. And from this one studio here, you can do all of that. And one of the cool things that was absolutely essential for our customers was the tight SQL Server integration. So I want to direct your attention to how easy it is to create a hybrid data store. So in SQL Server, I have, say, a product table. And what I want to do is migrate that product table over to a NoSQL cluster. And I've stood up a group here that has 4 servers in it, and I created a NoSQL data store just by specifying its name, the data store type, and this connection string here that you see. And the next thing that I needed to do was basically show or establish this ORM type mapping. And in the very near future, we're going to be supporting like standard and Hibernate type of ORM, so that the syntax is totally familiar if you're doing code first, for example. But basically, all I did is I specified the fields that I needed. I specified the column names that they were linked to, and the data types. And once I did that, all I have to do is hit import from SQL table. It transfers all of that record. I have just created a distributed NoSQL data store very, very easily. And conversely, if I wanted to manually export to SQL table, I could do that if I didn't want to have the automatic bindings. Now, I also set up a NoSQL store as a in-memory cache only. very much like a Redis or a memcached, in the right mode. And basically, the idea is that this is just acting as a cache for SQL Server data, and not as a separate NoSQL store. But what I wanted to, the reason I did that is I wanted to show the automatic bindings. Now, I made this little, weekend data viewer type of thing, just to show the SQL data and the FatDB data side by side. So on the left-hand pane, you can see the SQL data. This was taken from the AdventureWorks database. I just grabbed a product table type of thing, and you can see all the data that's in there. And you can see, and we just imported the NoSQL database, so I'm going to go ahead and refresh it. Same exact data. Pretty cool. Now, by the way, you can inspect this data that you see here in your NoSQL database from within the Management Studio itself. And the next release, we're going to have querying and stuff like that, so you're going to be able to write, very much like LinkPad, like ad hoc queries and stuff, and fire them off and get a result set. Also very cool. Now, let me show you the automatic bindings. So remember that cache that I was talking about? I set it up for having these automatic update bindings, right? And I'm going to view the same record set here with a SQL query versus a viewing the cached items. And if I go ahead and change this to pink, say, and update my local cache or distributed cache, I can see just by hitting refresh here, actually let me do a query, that pink was automatically propagated back. And the great thing is that these automatic bindings work both ways. Either I can do it from the FatDB side or I can do it from the SQL side. And they will stay in sync. We're pretty much unique in the field that we can actually do these automatic bindings, and I don't know of any other NoSQL database that has that. And finally, just from a code perspective, for those of you who are interested, I wanted to show you something cool, which was your link query syntax, right? So if you look here, this is your SQL grid query, and if you look down here, here's your FatDB link query. They're identical with the exception of the query provider. So essentially, you can make distributed link queries on your NoSQL database using your SQL Server, SQL link query syntax without changing hardly anything, and it just works. So I could go on for hours talking about the very interesting FatDB capabilities that are totally unique. I recommend that you guys check it out. It's cool stuff. So how do you want to take this, Chander? I can't hear you.
Sorry, I got muted over there.
Oh.
Well, yeah, one of the questions was that, I think with PDW, one of the questions was that it doesn't need Hadoop. Well, the answer to that is that if there's a business case that you have, it's probably better that we can answer what's the best solution for you rather than trying to evaluate technologies. Technologies are great, so let's say SQL Server, the responses might be great, but now try to write 400 million records into one table, put some kind of indexes that are not that good, or let's say come up with a cluster index whatsoever, don't make it sequential. It's just going to crumble. Now, it's easier for us to answer a question where because all technologies are great, right? What's your business case? It's easier to answer the question that way rather than being here and trying to be the benchmarks for technologies out there. That's definitely not our intention to put any technology down or say we're better, But for the most part, the business cases you have in the .NET field and the SQL Server field, I think FatDB has a great solution. Now, I mentioned in the beginning, right, I'm a big fan of Elasticsearch. So if you had a search solution, maybe only search solution, right, and you wanted something like that, you could go with that. Now, you're a financial firm, and you probably wanted to just try something else, and you just want to stick with SQL Server, that's fine. But again, the goal of this webinar is to make sure that we let you know that there's an option there that you can do Polyglot, which is what FatDB has been doing for 5 years now, and recently Microsoft also has recognized the value behind it. And doing it that simply in .NET is that something that I got excited about, and that's why I'm here. So I think we have more comments here. Someone, Glenn, says, thanks, really good information. We'll obtain more information, and they probably want to know how we can get more access in the sense, how do we download? And I heard that there's something like a 1 hour of free consulting you guys are doing with FatCloud, and you're probably allowing some free developer licenses for the rest of the life or something. Do you want to comment on that?
We just changed our pricing model to be very similar to what you would see in the open source Mongo camps. Great news for everybody. This technology that's been in development for 7 years is free. So if you want to use the community edition, stand it up in production, and reap all the benefits of it, all you got to do is download it and get a license key. If you want support, we're happy to provide support. That's our paid model, and you could get 2 levels of support depending upon your your SLA needs. But it's hard to argue with free.
So we've got Yuan Assenger. He says, thank you for your open-minded discussion of the options. Any news on becoming a partner with Microsoft Market Store?
Yes, we are actively pursuing Azure right now, and but I have to say, expect an Amazon Marketplace release before we do Azure. There are some facilitating aspects on the Amazon side that is going to make it easier for us just to push it out to Amazon first. We're also partnering with 2 other folks to potentially provide environments for folks who want, a 3rd and 4th alternative to Azure and Amazon.
Awesome. I think it went really well, and if you have any questions, feel free to email us. I'm not a FatCloud expert, Justin is, so if there's a question I can't answer, I'll definitely forward it to him. Thanks, everyone, for being here. Justin, thank you for being there, and if you have any comments.
Thanks, Chander. As always, it's a pleasure.
Thank you so much. Have a good one.
Take care.